Okay, so I wanted to finish up the two examples that we didn't get done. This one here, a little bit different from the last slide, right? We looked at this example number 3, said we were going to take the log of both sides and then use the power law to eventually isolate for x. Well, in this case, we don't actually have two powers. We instead have a single logarithmic expression. And actually, the fact that it's a single logarithmic expression means that we could almost treat this just as we did in, the kind of concepts from module 1, lesson 1. The fact that if it's just a single logarithmic expression, then we can rewrite it as a power. And given that this is log base 5, this means that log base 5 of that expression is equal to 2, so 5 to the power of 2 is actually equal to the expression in the brackets. And as soon as you see that step, really everything else is rather straightforward. So at this point, you're solving a linear equation. 25 is equal to 4 minus 3x. And so if we subtract 4 from both sides and divide by negative 3, we get our solution. And once again, you can check that, right? Plug that back in. If you plug that in here, you get negative 3 times negative 7 is 21. So 4 plus 21 is 25, and that's correct. Right? 5 raised to the exponent 2 is equal to 25. So this one here is actually a little bit easier once we just recognize that first step, which is, well, we've got a single expression, and we can rewrite that as a power. So last but not least, this one here. And this one, you might think, well, it's kind of similar to A. Part A, though, we only had really one term on each side, where one was a logarithm, so we could easily just rewrite it as an exponential equation. Well, in this case, we've got multiple terms. And there are a couple of approaches to this question. So one thing you could do is you could rearrange, move everything to one side of the equation first, but ultimately at some point you will need to combine terms together. Now if you move, for instance, this expression here, log of 4x minus 3 to the left, then it'll be negative, and you could perhaps use the difference law for logarithms. As it stands, however, on the left-hand side, we've got two expressions with the same base, right? They're both base 10. They're being added together. So in fact, we could use the product law for logarithms on the left-hand side. And then we could simplify that to turn into a single logarithmic expression. So this means that by the product law, we would take the product of the two things in the brackets. This gives us log of x plus 6 times x minus 2. With that said, we've got log on the right-hand side. And now, one of two things can happen. We can either move, as I said, once again, move this over to the left, combine it all together. But in fact, the easier route here is to recognize that, remember, if we can take the log of both sides as a means to evaluating an expression, then we can kind of go in the other direction as well. And we can actually undo this by simply just dropping the log of both sides, right? If the left-hand side log of base 10, if that expression is equal to this expression, then what's in the brackets must be the same. So this means naturally that what's inside, or x plus 6 times x minus 2, has to be equal to 4x minus 3. And now we're left with a quadratic equation, which we can just expand on the left. This will give us plus 6x minus 2x. And now if we move everything to one side of the equation, those 4x's cancel, and we get minus 12 plus 3 when it comes over, gives us minus 9 equal to 0. So this is just x minus 3 times x plus 3. And we have two solutions. We have the solution of positive 3 and negative 3. Now, there is only one valid solution. However, if we look to check those, notice that when we plug in the negative 3, the negative 3 actually gives us negative values inside two of the expressions. And in fact, we can't have that, right? There's no power of 10 that can give us, for instance, in this case, negative 3 minus 2 is negative 5. There is no power of 10 that can give us that. So even though there are two solutions from this quadratic expression, the negative value is what we say inadmissible. And so positive value is the only solution.